first function prime, e to 2x times the inner function prime times the second function, plus the first function times the second function prime. There is really nothing I should do here, just maybe factor out e to 2x and get 2 natural log x plus 1 over x. Any questions? Let's look at 2 more, and then I would like to look at some applications. Let's see where this pops up. And hopefully we can start chapter 4. So basically this was algebra review, part of it, and then differentiating the exponential and the log. Okay, let me show 84. In 84 we have natural log applied to e to the x minus 2. Same thing, we want to find f prime. Natural log of a function prime is 1 over the function times the inner function prime. So this is e to the x over e to the x minus 2. Do not attempt to simplify these two, please, please. 86. There are so many different types. So we have f of x equals natural log x to the 3rd power. Careful now, because here we have the chain rule combined with the power rule. So f prime, I bring 3 in front. I subtract 1 from the power, and I multiply by the inner function prime. Yes, I do see 87, which is different. Nobody stops me. Anyone? Any questions? Anyone, please? Any questions? So in 87, we have natural log applied to natural log of 8x. So f prime. I have natural log of a function. So then this must be 1 over the inner function, which happens to be natural log of 8x. Now I have to differentiate natural log of 8x, which is 1 over 8x. But it's multiplied by the innermost function prime, which is 8. So I can do this because they're factors, that's why I can. So then I have 1 over x natural log 8x as the final answer. Okay, I would like to look at the equation of a tangent line. So please choose if you'd like. If not, I will. 91, 92, 93, 94. 91 through 94. If you don't choose, I will.
92.
92, perfect, excellent. 92, we have find the equation of the line tangent to the graph of y equals natural log x raised to power 2 at x equals 3. I have to be given the point. I'm only given x. I will plug it in, and it's natural log 3 squared. So natural log 3 squared. So this is the point. This is the x, and this is the y value. Because if I want to determine the equation of the tangent line, I have y minus y1 equals the slope times x minus x1, where x1 is 3, and y1 will be natural log 3, everything squared.
Are you doing number 93? Yes.
Okay, I'm sorry. Yes. Sorry. Find the equation of the tangent line to the graph of y equals, sorry, e to 3x times natural log of 4x. Thank you very much. Sorry about that. When x equals 1. Perfect. So again, I need the point, 1 comma. So when I plug in 1, this is natural log 4. When I plug in 1, this is e cubed. E to the third natural log 4. That would be the y coordinate of the point. So e to the third, 4 times 1 is 4, natural log 4. This is the y coordinate. I may approximate it at the end. We'll see. So y minus y1 equals the slope times x minus x1, where x1 is 1. y1 is e to the third natural log 4, but I do not have the slope. I have to find the derivative and plug in 1. The derivative evaluated at 1 will give us this number. So m equals y prime at 1. Okay, now I see that the function is composed of a product of two functions. Both of them are function composition, so I will have to use the chain rule in both cases. The first function prime, e to u prime, is e to u, to a function, times the function prime, times the second function, plus the first function stays unchanged, times I have to differentiate the second function, which is 1 over 4x, times the inner function, which is 4. That's the only thing I can simplify. So I will write e to 3x, and this is 3 natural log 4x. This is out, plus 1 over x. Now I plug in 1, so y prime at 1. This will be e to the third. This will be 3 natural log 4, and this will be plus 1. And I have to approximate all these numbers because otherwise, let me write it first, and I can let you approximate them whenever you can. But this is not a tangent, right? I have to do something about it. Let me, before I don't want to put approximations because till the very end. So let me try and simplify if I can a little bit. So I distribute to x, and there is nothing I can do to that. 3 natural log 4 plus 1x. And then minus 3e to the third natural log 4 minus e to the third, and then plus e to the third natural log 4. And that's our y. No matter what I do, I can only combine these two. There is nothing else. So I have to use the calculator and give an approximation of this. So e to the third, where are you e? Here it is. E to the third, parentheses, 3 natural log 4, close, plus 1. 3 natural log 4 plus 1. Yeah. Okay, so this is roughly 103.62 x. And now I calculate all this, but I have negative 2 e to the third, because it's negative 3 plus 1. Negative 2 e to the third natural log 4, and then minus e to the third. Minus 75.77. So this is the equation of the tangent line to the graph of this at this point. Good pick. Weird function, but it is what it is. Okay. I would like now to look at applications. Yes, yes, please.
Can you do 93? Just
yes,
that one.
Yes, of course. The one that I started.
Yeah.
Okay. Yes. So I have. So I have y minus y1 equals the slope times x minus x1, and I know that these are, and the function was natural log x squared. Very good. So from here I have y prime is 2 natural log x, subtract 1 from the power, times the inner function prime. So now y prime at 3, because the point was 3. Yep. At 3 will be 2 natural log 3 divided by 3. And this is this number. So y minus natural log 3 squared equals 2 natural log 3 over 3 times x minus 3. So y equals 2 natural log 3 over 3x minus 2 natural log 3, because these two will cancel out, plus natural log 3 squared. So now I'll determine these numbers. 2 natural log 3 divided by 3. And I got 0.73. I don't know how many decimal digits they want. I stuck with 2. And now negative 2 natural log 3 plus parentheses natural log 3 squared. Negative 0.99. Okay, let's look at applications now. Yes, 104 on page 321. Any questions for me, please? Any questions?
What page was it again?
321. 104. The title is Forgetting. I guess we all get there. As part of a study, students in a psychology class took a final exam. They took equivalent forms of the exam as monthly intervals thereafter. After T months, the average score function of time, 78 minus 15 natural log t plus 1, of course, for t greater than or equal to 0, and t is in months. And this is the score. No measurement unit. What was the average score when they initially took the test? That is S of 0. What was the average score after 4 months? That's S of 4. I'm not going to put them in right now. I'm going to put the function in and determine all at once. Part C, S of 24. After 2 years. What percentage of their original answers did the students retain after 2 years? Okay. And then find S prime of t, and then find the max and the min, and then find the limit. Okay. So first, let's quickly answer these. Let's put the function in y equals. Clear if you have anything else. 78 minus natural log 15. natural log of x plus 1, close the parenthesis. 78 minus 15 natural log x plus 1. Go to second and table and plug in 0, plug in 4, and plug in 15. Oh, why 15? 24. Okay, so for 0, obviously we have 1. How do I know? It's natural log 1 is 0 times 15, so it's obviously 78. The next one is 53.86, and at 24 is 29.72. Part D. What percentage of their original answers 78, what percentage of their original answers did the students retain after 2 years? Okay, so they're asking us to divide 29.72 by 78. 29.72 divided by 78. So this is 0.3810, which is 38.1%. Approximately, of course, I rounded it. Then they're asking us to find S prime of t. Fine. S prime of t, the constant prime is 0, minus 15 stays. Natural log, when I differentiate, is 1 over the function times the inner function prime. Well, that's 1. So this is the answer. Find the maximum and minimum values if they exist. Okay. So t, S prime of t, and S of t. 0 to infinity. Well, you know what I mean. It's not really infinity. There are no critical numbers. S prime of t is never 0. A fraction is 0 if the top is 0, but 15 cannot be 0. So is this undefined? Yes, but at -1. A -1 does not fit in greater than or equal to 0. I see that this function is always negative, always. So the first derivative is always 0, then this must be, right here, this number, I didn't write it yet, must be the absolute max. We already have it. It's 78. So 78. So absolute max, 78. Final question. G, find the limit of S of t as t approaches infinity and discuss its meaning. So they want us to determine this right here, the limit. So let's determine that. Limit of 78 minus 15 natural log of t plus 1 as t approaches infinity. Okay. So when t approaches infinity, this expression will approach infinity. And now the question is, natural log of infinity. Well, we know the graph of natural log. We cannot forget that. This is the graph of natural log. When x approaches infinity, natural log will approach infinity. So now all this piece approaches infinity. But I have -15 in front. So -15 times infinity, this will approach -infinity. -infinity plus 78, who cares? Is -infinity. But when it comes to memory, there's no such thing. So the limit as t approaches infinity from this function s of t, it cannot be lower than 0. It will make no sense. So the least I can remember about anything is 0, not negative infinity. So in this situation, negative infinity will have no meaning. But that's the algebraic answer. If I didn't know what that function meant, the answer is correct. It's negative infinity. But not when it comes to memory. We cannot forget more than 0 or remember more than 0. Any questions?